All right, so number one, whenever you're adding two terms together, there's nothing to distribute, so we can rewrite this without the parentheses. So this plus negative 3x cubed, we can just write this as minus 3x cubed minus 4x squared plus 7x minus 1. And then we combine like terms. So 7x cubed minus 3x cubed is 4x cubed. 5x squared minus 4x squared is plus 1x squared. Negative 3x plus 7x is a plus 4x. And then a negative 4 minus 1 is a negative 5. So when we're adding, we just combine the like terms. When we're subtracting, what we do is we distribute this negative to everything in the second parenthesis. So the first parenthesis stays the same. But everything in the second parenthesis changes signs. So this would be a plus 3x cubed plus 4x squared minus 7x plus 1. So then when we combine, we'll get 10x cubed plus 9x squared minus 10x minus 3. Now 3. Whenever we are multiplying, we can only multiply 2 together at a time. So I'm basically just going to look at the first two parentheses here. And I'll multiply these two together first, and then I'll multiply it to the last parenthesis. So when I distribute, I got to distribute the 4x to both and the positive 1 to both. So this would give me 4x squared minus 20x. Distributing the 1 would give me a plus 1x minus 5. And again, we still have this 2x plus 3 on the outside. So I'll combine like terms. So that'll get 4x squared minus 19x minus 5 times the 2x plus 3. So now I need to distribute the 4x squared to both terms, which would give me, 8x cubed plus 12x squared. I'll then distribute the minus 19x to both terms, which gives me a minus 38x squared minus 57x. That's 57. And then I need to distribute the minus 5 to both. So this gives me a minus 10x minus 15. So that when I combine like terms, I can combine my x squareds and I can combine my x terms to get 8x cubed minus 26x squared minus 67x minus 15. Now for 3x plus 5 squared, when it's squared, we cannot distribute this squared to each term Can't do that. Squared means it's multiplied by itself. So this is 3x plus 5 times 3x plus 5. And then we can distribute here. So remember, everything in the first parenthesis needs to be multiplied to everything in the second parenthesis. So the 3x gets distributed and the 5. To get 9x squared plus 15x plus 15x plus 25, which would turn into 9x squared plus 30x plus 25. All right, long division. So we know that we need to use long division because there's a number in front of the x, okay? We can only use synthetic division when it's x plus or minus a number. So we're going to put the 2x minus 2 on the outside of our long division sign. And on the inside is going to go 8x cubed plus 6x squared plus 0x minus 9. So we need to make sure that we have a placeholder here. So we always start off by dividing our first two terms. So 8x cubed divided by 2x is 4x squared. This goes on top. I'm then going to multiply the 4x squared to both terms on the outside. So 4x squared times 2x gives me 8x cubed minus 8x squared. Now we need to carefully subtract down. The 8x cubes cancel out. 6x squared minus negative 8x squared is 14x squared. Bring down the plus 0x. And then we repeat. So we divide our first two terms. So this would be 14x squared divided by 2x, which would be 7x. This goes on top. We then multiply the 7x times the 2x minus 2, which would give us 14x squared minus 14x. Subtract down. To get 14x. Bring down the minus 9. And then repeat. So we'll divide 14x divided by 2x to get 7. So we put a plus 7 on top. Multiply the 7 to the 2x minus 2 to get 4x minus 14. Subtract down. To get 5. And this 5 is our remainder because 2x does not go into 5. So our answer is 4x squared plus 7x plus 7 plus 5 over 2x minus 2. Now synthetic division, I know I'm using synthetic division, or I can use synthetic, because what I'm dividing by is just x plus or minus some number. There's no term in front of the x, there's no x squared. So remember, in our half box, we take the opposite of the number that we're dividing by. So since we're dividing by an x minus 3, we'd put a positive 3 in our half box. We then list off our coefficients. So 4x cubed, 2x squared, negative 6x, positive 3. Skip a space and draw a line. Bring the 4 down below the line. Anything below the line gets multiplied to the number in our half box. So 3 times 4 is 12. Add down. 14 is now below the line, so 3 times 14 is 42. Add down to get 36. Multiply to get 108. Add down to get 111. This 111 here is our remainder. And everything goes down by 1 degree. So this started as an x cubed. This goes down to an x squared. So this should be 4x squared plus 14x plus 36 plus 111 over x minus 3. All right, what is the remainder when the two polynomials are divided? So we need to use long division because x squared plus 2x plus 1 is not in the form of x plus or minus a number. So outside goes x squared plus 2x plus 1. Inside goes x to the 4th plus 0x cubed plus 2x squared plus 8x minus 6. So again, we start off by dividing our first two terms. X to the 4th divided by x squared gives me x squared. This goes on top. We then multiply x squared times the 2x, x squared plus 2x plus 1. We put all three terms below. So we'll get x to the 4th plus 2x cubed plus x squared. And we subtract down. This would give us negative 2x cubed plus 1x squared plus 8x. Divide the first two terms. So negative 2x cubed divided by x squared is negative 2x. So we put a negative 2x on top. We distribute the negative 2x to all three terms on the outside, which would give us negative 2x cubed minus 4x squared minus 2x. And then we subtract down. This would give us 5x squared plus 10x minus 6. Divide our first two terms. So 5x squared divided by x squared is 5. So we put a plus 5 on top and then distribute the 5 to all three terms on the outside to get 5x squared plus 10x plus 5. Subtract down. And I get negative 11. Negative 11 is my remainder, and this is what the question is asking for. It is possible to, if our x term didn't cancel out, to have two terms as our remainder. All right, so as a review, your end behavior is determined by both your degree and by your leading coefficient. So remember, if your degree is odd, these are going in opposite directions. So if your leading coefficient is positive, this means on the right side you're going up. So if they're going in opposite directions, the left side needs to go down. If your leading coefficient is negative, that means the right side's going down. So your left side is going up. Now, if your degree is even, they are going in the same direction. So if the leading coefficient is positive, the right side goes up. So the left side also goes up. If your leading coefficient is negative, the right side goes down. And if it's even, they're going in the same direction. So the left side also goes down. So if I'm asked for the end behavior, I'm going to find the degree, which is the biggest exponent. So my degree here is 4, which is an even number. My leading coefficient is the number that is with the variable that has that degree of 4. So this would be -5, which is negative. So since it has an even degree, they're going in the same direction. Negative means that direction is down and down. Now when we're finding their zeros, we're going to find their zeros and their multiplicities. We're going to set each zero equal, or each factor equal to 0. So 3x cubed equals 0. X plus 5 equals 0. X minus 2 equals 0. And then I solve. So if I divide each side by 3, I get x cubed equals 0, which means x equals 0. Subtract 5 from each side, so x equals -5. Add 2, so x equals 2. And then their multiplicities. So at x equals 0, this had a multiplicity of 3 because of the cubed, which means it's going to go through at that 0. Remember, odd multiplicities go through. At -5, this had a multiplicity of 2 because it was squared. So it's going to bounce off or just touch it. And x minus 2, when there's no exponent written, this is an exponent of 1, so it had a multiplicity of 1, which means it's odd, so it's going to go through that 0. So graphs, we need to combine the end behavior with the leading coefficients. So if I look at this first graph, I've got zeros at -3, -2, and -1. And it's going through, so it's an odd multiplicity. It's going through, so it's an odd multiplicity. And it's going through, so it's an odd multiplicity. So this graph, or equation, could be x plus 3 times x plus 2 times x minus 1. And the end behavior, it's going up on the right and down, so it's positive and odd, which matches up. Now here, I've got 3 zeros for this one as well. Since it is bouncing off at -1, it has an even exponent. At 2, it's going through, so it has an odd. And at 4, it's going through, so it has an odd. So this one could be x plus 1 squared, because it's bouncing off. Then x minus 2 cubed, because it's going through. Then x minus 4 to the first power. Now, because my end behavior is down and down, that means I need a negative with it. So I'm going to put a negative out in front. And my last one, I have an odd exponent at -3, an even exponent at 2, and an odd exponent at 5. So this would be x plus 3, either to the first or third or some odd number. X minus 2 squared, because it's going to have an even exponent. And then x minus 5 to the first or third. It's going up and up, so that's positive, so we're good. All right, factoring review. So this first one, we need to determine what method we're going to use. We are going to use the sum/difference of cubes. Because these are two perfect cube numbers. So our formula for this, remember, is when we are adding or subtracting two perfect cubes, this factors into a plus or minus b, a squared minus plus ab plus b squared. We also referred to this as SOAP to talk about our signs. Same sign, opposite sign, always positive. So for this problem, 8x cubed, this would be 2x to the third power. So I'm going to let all my a's be 2x. 343 is 7 to the third power, so I'm going to let all the b's be 7. So this would be 2x plus 7, 4x squared minus 14x plus 49. So a plus b, a squared, opposite sign, a times b. So 2x times 7 is 14x. Always positive, plus b squared, so plus 49. Two. Now, neither of these numbers are perfect cube numbers, but they are perfect square numbers. We can take the square root. So we are going to use difference of squares on these. So that's where we take the square roots. One is plus and one is minus. So y squared plus 9 times y squared minus 9. Now again, y squared minus 9 is again a difference of squares. We could factor the y squared plus 9 using i's, but we're not going to do that. So we have a y plus 3 and a y minus 3. And the y squared plus 9 is still just hanging out. Three, 4 terms means we're going to factor by grouping. So I'm going to draw parentheses around the first two and parentheses around the second two. I'm going to GCF each parenthesis. So my GCF of the first parenthesis is x squared. This leaves me with a 2x plus 3. My GCF of the second parenthesis, between negative 50x and negative 75, is negative 50. Not negative 50, negative 25. So I factor out a minus 25, which leaves me with a 2x plus 3. Notice the 2x plus 3's are the same, so that's my first parenthesis. My second parenthesis is the x squared minus 25. Now, a lot of times we can stop here, but this x squared minus 25 is a difference of squares. So we can factor this using an x plus 5 and an x minus 5. And then 4. First thing I notice is that I can factor out a GCF of 2x from each term. So I put a 2x on the outside, which leaves me with x to the 4th minus 4x squared minus 21. And then this inside is set up like a factor sum. So I'm looking for factors of negative 21 that have a sum of negative 4. So it should be negative 7 and positive 3. Since this is an x to the 4th, it splits into an x squared minus 7 and an x squared plus 3. Check to see neither of these are perfect squares, so we'll stop here. All right, now finding all the zeros of a function. This cannot be factored because it doesn't follow our pattern, because this again is similar to x cubed minus 4x squared plus 0x plus 8. So first we're going to list off our possible rational zeros. Or possible rational roots. Now to do this, we take factors of our last number. So here factors of 8 divided by factors of our first number. So factors of 8, numbers that multiply to 8, are 1 and 8, and then 2 and 4. Factors of 1 are just 1 and 1. And this is where we kind of made our table. So 1 divided by 1 is 1, and the negative version. 2 divided by 1 is 2, and the negative version. 4 and negative 4. 8 and negative 8. And then what we're going to do is we are either going to plug these numbers in or use synthetic division. So when we plug them in for x, or we use synthetic division with it. So for example, if I was trying to do 1, I'd plug 1 in. So this would be 1 cubed minus 4 times 1 squared plus 8. And when I do this in my calculator, I get 5. I could have also done synthetic division. So if I wanted to do synthetic division with 1, and then remember I list off my coefficients. So 1, 4, 0, 8. So we bring the 1 down below the line. Oop, this should be a negative 4, which would give me negative 3. Which again gives me 5. So it's the same term. It doesn't matter which one we use. So when we do that, we're only really looking for the ones that give us 0. So if I try negative 1, I get 3. When I try 2, I get 0. And I don't really care about these other ones. I just care about the fact that I got 0 here. So what I'm going to do is use synthetic division with 0. Sorry, with 2, because it gave me 0. Remember, 1, negative 4, 0, 8. So this was an x cubed, x squared, x number. So now this is a 1x squared minus 2x minus 4. And we can use the quadratic formula with this. We're again, a equals 1, b equals -2, and c equals -4. So x equals -b, so that turns into a +2, plus or minus the square root of b squared minus 4ac all over 2a. So 2 plus or minus the square root, this would be a +4 plus 16 all over 2. This would be the square root of 20 over 2. Now the square root of 20 we can simplify. This is the square root of 4 times the square root of 5. The square root of 4 is 2. So this is 2 plus or minus 2 square roots of 5 over 2. And then I can divide. So x equals 1 plus or minus the square root of 5. I also, again, had x equals 2 from my table. So those are my answers. All right. So when functions are even, they are symmetric about the y-axis. So for example, the even graphs get cut in half along the y-axis. I'll do it in green. So the same on the left and the right. When a function is symmetric about the origin, that means it's symmetric about the point 0, 0. So if I have something in the top right quadrant, it should match up in the bottom left quadrant. Or if I have something in the bottom right quadrant, it should match up in the top left. They should be across the origin. Now, if neither of these graphs, if it doesn't match up in any of them, then it is neither even nor odd. Now, looking at an equation, to tell if a function is even, when you plug in a -x, you get the exact same function out. So, for example, if I plug in a -x here, 5 -x to the 4th minus 2 -x squared plus 7. This -x to the 4th is -x times -x times -x times -x. And whenever it's an even, a negative times a negative is a positive, and a negative times a negative is a positive. So this is just x to the 4th. So this is just 5x to the 4th. Same thing when it's an even exponent of 2. So 2x squared, the negative goes away. And the plus 7. This is the exact same thing that we started with, which makes the function even. Another way you could check is that all has even exponents. Ms. Cooper, what about the 7? Well, this is technically x to the 0 power because there's no x there. So all of these have even exponents. Now, when a function is odd, plugging in the -x gives you the exact opposite of what you started with. And so f of -x equals 4 -x to the 3rd minus 6 times -x. Well, this -x cubed is -x times -x times -x. Well, again, a negative times a negative is a positive. So 2 of those negatives cancel out. but that last negative doesn't have anything to cancel out with, which makes this negative x cubed. So that negative will now go with the 4, so this will be negative 4x cubed. 6 and the negative x would make this a plus 6x. This is the exact opposite of what we started with, which makes this function odd. Another way you could look is that all of the exponents are odd. So this is 3, exponent on the x is 1. All right, so when we're talking about cubic and quartic functions, these are our parent functions. And remember, for our parent functions, for the cubic one, we count to like our center point. For the quartic one, we count to our vertex point. So our expectations of these is that we can identify the transformations and then write the equations of the graphs. All right, so we can say that for this function, our base function is an x cubed because of the cubed. The negative in front is going to reflect over the x-axis. The 2 is going to be a vertical stretch by 2. The minus 1, remember anything inside moves it left and right, and it's opposite of what you think. Just going to move our graph right 1. And then the plus 4 on the outside is going to move our graph up 4. And these rules would follow the same for if it was x to the 4th. All right, now this problem, this is an x to the 4th problem. And again, we're comparing it to our parent functions. So if it's an x cubed graph, it'll look like this. If it's an x to the 4th graph, it'll look like this. So this one's an x to the 4th, and we count to our vertex point. So it has gone right 1, up 3, and it has been reflected because it's opening down. So when I write my equation, reflected is going to be a negative x to the 4th. To go right 1, this would be a minus 1 on the inside. And then to go up 3 would be a plus 3 on the outside. Y equals, or f of x equals